Welcome to the CSUN video learning module on the difference between elements, compounds, mixtures, and pure substances. My name is Simon Garrett. In this video, we'll illustrate some basic terms used to describe matter. You won't need a calculator, but a periodic table might be handy. You should review your notes and text before starting this video. So to business. Here comes your first example. Question 1. Identify each of the following as a chemical element or compound. Iron, sodium chloride, Hg, Al2O3, ammonium sulfate. Pause the video here while you decide. Ready? The first substance is an element. It is one of the substances whose symbol, Fe, is on the periodic table. All substances on the periodic table are elements. Sodium chloride is not found on the periodic table, so it cannot be an element. Sodium and chlorine are found on the periodic table, and this name combines these elements just like a chemical compound is two or more elements chemically combined. Hg. This is a chemical symbol for mercury. Since this symbol is found on the periodic table, atomic number 80, it is an element. Al2O3. Again, this is not found on the periodic table, so it cannot be an element. It must be a compound. In fact, it's the compound formed when aluminum and oxygen chemically combine to make aluminum oxide. Ammonium sulfate. This is tough because we might not know the chemical formula of ammonium sulfate. It is actually NH4 twice, SO4. Regardless, even if we didn't know this, we would not find anything named ammonium sulfate on the periodic table, so it must be a compound. Question 2. Identify each of the following as a chemical element or compound. NH4 twice, SO4, SNO2, H2, calcium chloride, sodium hydrogen carbonate. Pause the video here while you write down your answers. Okay, the first substance is a compound. It is not one of the substances whose symbol is on the periodic table. It's a chemical formula including 4 elements combined. This is ammonium sulfate. Whenever we write a chemical formula with no spaces between the symbols, we mean that these elements are connected or chemically bonded to each other. The next substance is also a compound. It is a chemical formula including 2 elements, tin, Sn, and oxygen, O, chemically combined. This is the compound tin 4 oxide. H2. We have to be careful with this one. It's a chemical formula, so our first guess might be that this is a compound. But a compound is defined as 2 or more different chemical elements combined. This is only one element, hydrogen, so this cannot be a compound. Calcium chloride. There are 2 elements in this name, so it cannot be an element. It's a compound. Sodium hydrogen carbonate. This one is tricky because so far we've only met chemical compound names that have 2 parts, like calcium chloride. But some have 3 or more parts, like this one. Regardless, it cannot be an element because we can see that there are multiple elements here. A name or chemical formula always implies the elements are chemically combined. So this is a compound whose chemical formula is NaHCO3. Question 3. Identify each of the following as a compound or mixture. Kf, salt water, steel, milk, Fe2O3. Pause the video here and jot down your answers. Here we go. The first substance is a compound. By now, I hope you can recognize that a compound is made of 2 or more different chemical elements. In this case, potassium and fluorine, chemically combined in potassium fluoride. We can write a chemical formula, like here, or a name. Regardless, potassium fluoride's chemical formula tells us that this compound is made of equal parts K and F, and this compound cannot be made any other composition. Salt water is a mixture. Why? Because salt water can be made in any number of ways. We can add a little salt or a lot of salt. We still make salt water. In other words, mixtures have a composition that can be variable. Perhaps you don't know much about steel, but it's a mixture, mostly of iron and carbon. But it can be made with different amounts of these elements, so its composition can be varied. The result is still steel, just different kinds of steel. Compounds have fixed compositions. Mixtures have variable compositions. Milk. Milk is a mixture because it contains variable amounts of water and milk fat, 2%, 1%, or fat-free. It's still milk, but the compositions are not the same. Fe2O3 is iron 3 oxide. It contains 2 atoms of iron for every 3 atoms of oxygen, according to its chemical formula. As such, its composition is fixed, and it must be a compound. Try this one. Identify each of the following as a compound or mixture. Wood, air, water, NH3, gasoline. Pause, play back, and write down your answers. Okay, the first substance is a mixture. There are many different kinds of wood, made mostly of carbon, hydrogen, oxygen, and nitrogen atoms, and each wood must have a slightly different composition. So wood is a mixture because of its variable composition. Air is a mixture too. Air is mostly made of nitrogen and oxygen, and a small amount of argon. But these proportions can change because the elements are not chemically combined or joined to each other. The air at the top of Mount Everest has less oxygen in it, but it's still air. Water is a compound, H2O. The chemical formula tells us that water can only be made from 2 parts hydrogen and 1 part oxygen. Any other combination is not water. So water is a compound. It has a fixed composition. NH3 is ammonia. Again, the chemical formula tells us the composition is fixed. 1 atom of nitrogen is chemically combined with 3 atoms of hydrogen. They cannot be combined in any other way to make ammonia, a compound. Gasoline is a mixture. Although gasoline is mostly carbon, hydrogen, and oxygen atoms, its composition is variable. Not all gasoline is the same. You can buy different grades of gasoline, 87, 89, or 91 octane, for example, each one of which has a slightly different composition. Gasoline must be a mixture. Question 5. Identify each of the following as pure or not pure substances. Air, salt water, water, calcium, granola. Pause the video here and write down some answers. The first is not a pure substance. We already know that the composition of air can vary. Pure substances have a fixed composition, so air cannot be a pure substance. Salt water is a mixture, and its composition can vary. A variable composition must mean this is not a pure substance. In contrast to salt water, the composition of water is fixed. It is a compound made of fixed amounts of H and O. By definition, something with a fixed composition is a pure substance. All chemical compounds are pure substances. Ca. Ca is calcium. Calcium is made only of calcium atoms. It cannot be made any other way, and its composition cannot change. If you add anything else, it is not calcium. A fixed composition means it is a pure substance. All chemical elements are pure substances. Granola, yum. But granola can be made many ways. More raisins, more flakes, less oats. Despite what the box may say, granola is not a pure substance in the chemical meaning of the word pure. It has a variable composition. Question 6. Identify each of the following as pure or not pure substances. Milk, copper, CaCO3, O2, concrete. Pause the video here while you think about your answers. The first is not a pure substance. Milk, fat-free, 1%, 2%, has a variable composition, so it cannot be a pure substance. Copper is made only of copper atoms. It cannot be made any other way, and its composition cannot change. A fixed composition means it's a pure substance. Remember, all chemical elements are pure substances. The composition of calcium carbonate is determined by its chemical formula and is fixed. By definition, something with a fixed composition is a pure substance. Remember, all chemical compounds are pure substances. Just like B, oxygen is a chemical element whose composition is fixed, so it must be a pure substance. Concrete can be made many ways by mixing sand, water, stones, and cement. Since it has a variable composition, it cannot be a pure substance. Let's turn our attention to the two kinds of mixtures we'll meet in this class. Question 7. Identify each of the following as homogeneous or heterogeneous mixtures. Milk, sugar dissolved in water, steel, granola, gasoline. Pause the video here while you write down your answers. The first is a homogeneous mixture. It looks the same to the unaided eye all the way through. The second is a homogeneous mixture. When sugar dissolves in water, it makes a solution that looks like water. It looks the same to the unaided eye all the way through, so it's called homogeneous. Homo means same. The third is a homogeneous mixture. When you cut a piece of steel to see the inside, it looks the same to the unaided eye all the way through, so it's homogeneous. By the way, the surface may look different if rust or iron oxide has formed on it. The fourth is a heterogeneous mixture. Granola doesn't look uniform. Sometimes I see raisins, sometimes flakes, sometimes oats. If it does not look the same to the unaided eye all the way through, it's called heterogeneous. Hetero means different. Lastly, gasoline. Gasoline is a homogeneous mixture. It looks uniform throughout to the unaided eye, like yellowish liquid. Last question. Identify each of the following as homogeneous or heterogeneous mixtures and identify the number of phases present. Ice water, salt water, oil and vinegar salad dressing, sugar, salt, and sand stirred together, red paint. Pause the video here while you figure out the answers. Ice water is a heterogeneous mixture. I can see regions containing ice and regions containing water. These are really different forms, two different phases of the same substance, but the mixture does not look uniform. Any heterogeneous mixture must, by definition, have two or more phases. Salt water is a homogeneous mixture. It looks the same to the unaided eye all the way through. It has one phase, a substance with a uniform composition throughout. Oil and vinegar salad dressing is a heterogeneous mixture. Since the oil and vinegar don't mix, the dressing looks different depending on where you look. If you shake the dressing very vigorously, you can get something that looks almost homogeneous. But if it sits for a few minutes, it will separate back to the heterogeneous form again. Two separate phases, one oil, one vinegar. Sugar, salt, and sand form a solid mixture with individual and separate grains. If it does not look the same to the unaided eye all the way through, it must be heterogeneous. There are three separate phases, one sugar, one salt, and one sand. Even though the sugar and the salt might look similar, They are different substances, and so form two different phases. Red paint is a homogeneous mixture. It looks uniform throughout to the unaided eye. Any homogeneous mixture must, by definition, have only one phase. So how did you make out? Let's review. Elements are the simplest chemical substances and are found on the periodic table. They are pure substances. Compounds are made from elements, chemically joining or bonding them together in fixed proportions. They may be represented by a name, like sodium chloride, or a chemical formula, like NaCl. Mixtures are made from multiple substances and are not chemically combined. They do not have chemical formulas and can be made from various proportions of the ingredients. Heterogeneous mixtures are mixtures that have regions of different composition when viewed with the unaided eye. They always have two or more phases. In contrast, homogeneous mixtures are mixtures that do not have regions of different composition when viewed with the unaided eye. They always have one phase. Pure substances have a fixed composition. As such, all elements and compounds are pure substances, but mixtures are not.